The following audio recording has been designed for learning purposes only. Do not share, distribute, or provide any type of copies, or this audio lesson will not be made available to you. Good luck with today's lesson.
I mean, what used to be, $5,000 investment, a $10,000 investment is now 10 million, 50 million, 60 million, 200 million. I think the largest investment so far that I've seen is somewhere on the order of $300 million. And I think it was BlackRock that went in and stuck money into it. So they're not taking their money, for example, and putting it into sort of classic companies, manufacturing firms or standard sort of banking and things of this nature, right? They're turning around and they're sticking it in here. Why do you think that is? And it's really pretty obvious if you step back and think about it.
The rate of return is on investments higher. Like, do you make more money?
No, go ahead.
You make more money. I mean, it's like it's very likely that you hire a couple analysts and stuff. You can pick out which one of these tech startups is most likely going to do very well. And you just throw money into it. Well, not even a tech startup, but like a lot of these emerging technologies in general.
Well, maybe. I'm talking about straight up game companies like Unity or something like that. Money being stuck in, right, into that, right? So it's not a bad idea, right? The tech startup sort of investment, but step back and think for a second, okay? Who are the main people playing games? Younger folks, right? Younger folks in general, okay? Are they watching standard TV?
No.
Are they listening to standard radio? What are they doing?
They're under subscription services for everything.
Which is managed, their marketing schemes for those things are managed by who?
Adults.
Well, yeah, I mean adults, but more importantly, those streaming companies,
Mm-hmm.
right? And if you've been paying attention to all of that streaming stuff, the costs are getting crazy. Like Netflix apparently is going to go out of business or something here soon, right? Or they're going to raise their subscription costs some crazy amount of money, right? My point is, guess what the new advertising channel is? And like I said, we've mentioned this over the semester.
Taking information, putting things on social media and whatnot.
Putting it into the game world.
Yeah.
They want a channel into the game world. Well, this will get you that channel, right? Direct marketing, right to the next generation of what? Money. The next generation of money. So if they can hook you now, 5, 10 years from now, when you've actually got an income and so forth. Yes?
I was going to mention, I do remember, I think it was like 2 or 3 years ago, I was playing a game, and I remember seeing a billboard in it that was for a movie that was coming out at the time.
Oh, there's the subliminal messages and all that. And guess what else is really, really important here, right? There's no controls in any of these places yet. There is on regular TV, regular radio, regular everything, right? There's all kinds of controls that says, you can't do this, you can't send that message, you can't, right? Well, over here, open market, you can do whatever your heart desires, and especially when you're sinking this kind of cash into this, right? Pay attention in the next 12 months, right? You're going to see election campaign stuff popping up in video games. Just watch, right? Because they know, certain campaigns know that their message works better with younger people. You will see that, right? And not just that. I mean, just general marketing and marketing in general. So there's that topic. There's this topic, right? There's a technology conversation, right? Technology topic, right? All kinds of tech happening. All kinds. We're going to look at some software ones and some hardware ones that are happening, right? The AR, VR thing is, like I said, going crazy. The interesting part about it is one of them in particular that's like number one or number two right now has their own operating system. Think about that. Has some very interesting repercussions. Okay, it's not owned by Microsoft, for example. Okay, so technology stuff. And then last but not least, and probably, in my opinion, one of the more important things, right? And that's sort of social slash underserved populations. And this to me is really sort of an interesting one, right? This guy here, right? You know, and I've said this for years already, we're like rock and roll in the 50s, right? So rock and roll in the 50s, everybody thought it was the devil's music and all of this kind of stuff, right? Well, we are now being blamed for a lot of bad things, and it's really sort of coming to a boiling point again, right? There's all of these sort of mass shootings that have happened and things like this, and everybody thinks it's the video game industry that's caused these things, right? Kids sitting in their basements, isolated, et cetera, you know, that have potential issues, and they pick up their gun and walk to a school someplace or to a big public location and start shooting. And they seem to think this has something to do with that, right? So the call to change the target for video games is becoming louder and louder. It calmed down for a while, right? But it's starting to escalate again because we've had a number of sort of these kinds of things happen, right? Everybody get what I'm saying here? So the political machine is going to get involved with the sort of the message of the games. In other words, we're going to put a limit on shooting, boys and girls, okay? And we're going to have you make games that do something else, right? Well, that's an interesting thought, okay? But this message, right? Then we've got this message, right? So let me ask you this. If I ask you who are the two groups that are not served in the game industry, what two groups really struggle? And the problem and the issue becomes this. One of them in particular has a considerable amount of money that could become useful.
Well, I think women is probably the highest one.
Which one?
Women?
Nope.
The elder.
Not specific.
Folks?
Who said that? The elderly. And there's been shots made at trying to bring them into the fold. Right? Everybody remember Wii Sports?
Mm-hmm.
That was an attempt to get older folks involved in video games. And not only that, get them up off the couch and doing something, right? It was a great idea, but it kind of fell short, right? Because they had to convince, for example, some of these old, assisted living places and so forth and so on to sort of really invest in this and put up programs to get people involved. I mean, I remember myself fooling around with like Wii Tennis or something, right? They had some sort of mechanism of tracking what you were doing, right? They had Wii bowling and all this, right? It was okay, but we're still missing an opportunity here. And those folks, yes sir, they've got cash that hasn't been tapped yet, right? That's part one. The other one group that's really struggled, right? That we've struggled in sort of being able to bring them in, right? To do stuff to get them is who? Who's the other group? There's two groups that really are having issues. It's not women. It was women for a while, but women have kind of resurged here a little bit, right? They're on the incline in playing games. Think about it for a minute. Any thoughts? Any ideas?
People with one hand.
With what?
People with only one hand.
Well, you're in the right location.
I'm disabled.
Handicapped folks. Handicapped. So, and particularly people who are blind. Right? This is a particularly difficult arena to get into. Does that make sense? So being able to sort of create games that would allow them to be part of it too. Right? There's been a few attempts. We're going to look at one of them. Right? That's kind of an interesting shot at it. So let's take each one of these sort of and really sort of talk about them. Okay? All right.
How do we blit an image to somebody's eyeball?
Well, that's another problem. That depends on the malady. That depends on the malady, right? I mean, we have the ability to set up something that will do it like a retina connection, right? But if the issue is the fact that that's not there, then you have a problem.
Yeah, a lot of people don't have. They have all the things, just the brain and retina. So that wouldn't do anything. But
all right, let me look at my stick here. Let's take a look at some of these topics. Right. Anyway, so these are like the general topics for today, and we're going to look at examples and talk about each one of them, okay, to get a perspective. I know you're there. It's there. So let's look at this guy. All right, so some of this stuff we may have looked at already, but just in case we haven't, right? These are some very interesting things. So, as you might imagine, right, everybody's involved in this space. Everybody's working on this stuff. Everybody's doing something in this field. There isn't a school, a business that is not dealing in the space of games. Right? Even MIT is involved in games. Let's take a look at one of their more recent components from the MIT Game Lab. And this is already a few years old.
People think that relativity is extremely weird. And the reason for that is just that we do not grow up with it. And the deeper reason for that is that it only really becomes apparent when objects are moving very close to the speed of light. And in everyday life, we just don't do that.
The goal of the project was to make something familiar that was very unfamiliar. The laws of special relativity, what would they look like in a familiar setting? With the gameplay, we actually took a very familiar type of gameplay, an object collection mechanic, and made that unfamiliar. So in an interesting way, we're kind of giving players what seems at the outset like a laughably simple task, just collecting 100 objects that are visible, that are strewn around a level. There's not really much blocking you from getting them. As gameplay proceeds, though, it turns out to be a much more difficult task than you might have imagined at the beginning.
The idea of the game was that we artificially lower the speed of light. Every time that you pick up one of the little objects in the game, light gets a little slower. That means that everyday velocities, the character walking around, is becoming closer and closer to the speed of light, and thus the world around you becomes increasingly relativistic.
If it were human scaled and at walking pace, then the thought is that it would be easier for the player to get acclimated to these effects because it's really familiar, you know, like it's just walking. You walk every day. Now here it is with relativistic speeds.
We are developing this game open source, so the code that gets developed in this lab here is going to be available to anybody who later on would like to build on this. It's like a relativistic game engine. So if people would like to develop games that also are taking place in the same kind of environment, they can take what was built here and then enhance upon it and put different games into the same engine. So I hope this also appeals to other game developers.
A Slower Speed of Light is the kind of game that I think people expect to come out from the MIT Game Lab. It's a game about physics. It's a game about something very, very complex made very tangible. It conveys some of the joy that theoretical physicists actually experience every day when they're dealing with these very, very interesting issues about the real world. So we see that games can be a very, very powerful medium for sharing some of the really interesting things that MIT researchers are working on with the rest of the general gaming public.
So Bungie's using this to develop a game, right? They've been working at it for a couple of years to get the mechanic done. It's pretty cool. It's a very cool thing.
They built basically a game engine that, so there's very realistic representation. It's real.
The theory of relativity.
Yeah. So like freaking how light travels and everything, right?
Yes. The impact. You pick up an object, and it's slow. It drops the speed of light slightly each time, right? So as the game goes on, the mechanic gets more difficult to execute.
But the thing is that it's not the game that's interesting, it's the fact that they built a system to be able to manipulate.
Well, let's think about what we said quite a while ago now, right? You are God in that little game world, right? Does that make sense? So you can define the physics that go on in that little game world, and that's literally what they did, right? They defined the theory, right, for that game world. Okay. So, since we're on the East Coast, let's go to the West Coast.
Oh, we're close to the Matrix.
Let's go to the West Coast for a minute. Awesome. If you ever get a chance to go to MIT, please do. Anybody gone to MIT? Just to like go to Cambridge and walk around at the school and stuff? If you look at the names on the doors in the computer science department, it reads like the who's who of computer science, right? And for one school, and here's the other school. The West Coast, of course, will not be outdone. So here's their gig. My other favorite school, Stanford. Another one, if you ever get the chance, go there.
Stanford University.
You don't think? I think so.
The autonomic system is the part of the brain that changes when you get excited or when you're happy or when you're sad. We want to measure the autonomic activity in the context of video game play. You can measure this directly from the brain, or you can do what we are doing, which is sensing peripheral signals. So the autonomic system also affects your heart rate, your skin temperature, your respiration rate. So we want to tell if the person playing a video game is excited, are they enjoying it, are they engaged in the game, are they happy. This is a modified Xbox controller, but we've taken the bottom part out of a regular Xbox controller and put in various physiological sensors. So we have a photoplethysmograph measurement. We can get the pulse from the optical measurement, as well as we have 4 electric plates on the side. And from that we can calculate the electrical beat of the heart, as well as the respiration rate. So what you see on the screen here is the biosignals coming directly out of the video game controller. So on the top here, we have the photo-based pulse measurement, and on the second line, it's the respiration rate.
That?
So that shows how much air is going into the player's lungs or out of the lungs. The third line is the accelerometer, so we can tell how much the player's hands are moving. On the fourth line, what we try to do is correlate this with the game activity. So this is a measurement we have of the video in the game. Eventually, we want to figure out a way to sense how the player is feeling about the game and then control the game. One example would be if the player wants to be maximally engaged, like they want to play a really exciting game, then what we can do is sense when they get bored. So say if their heart rate goes down or the respiration rate goes down, then we can say send in more zombies in the game. Or a lot of parents are concerned that their children are getting too involved in the game or too excited, and in the same way we can sense how they're feeling and tune it down for them.
So they can manage the game from your behavior. Guess what they're
For
employing?
more, please visit us at
framework.
stanford.edu.
Right? Let's look at a few more items here. Let's see. All right. Here, let's go to this guy here.
Jen, you gotta help me. The gravity's broken.
Come on, reality. Where'd that go?
Unless you've been living under a rock for the past few years, you've likely heard of augmented reality. You've probably even used it already. Ever sent a Snapchat with a filter on it? That's a classic example of AR. Remember when Pokemon Go fever captured the attention of the world? That's AR in action. Although it may not get the same level of media attention as its sexy cousin, virtual reality, augmented reality has the potential to dramatically change how we work, play, and learn. From schools to the workplace, in your living room and on the road, here are 5 groundbreaking examples of augmented reality hardware that are changing the way we interact with our world. Kicking things off at number 5, we've got the Navion from Weiray, the first holographic navigation system for cars.
Tesla's
Navion employs an advanced augmented reality interface that provides you with clear directions and a wealth of helpful information designed to get you where you need to go as quickly and safely as possible. Navion's holographic optical element serves as the heart of this device, creating a real AR experience right in front of your car. No special eyewear or headgear required. It has a built-in full HD camera and advanced inertial sensors, which it uses to continuously map the world around it relative to the vehicle's current position through a process known as simultaneous localization and mapping, or SLAM for short. On the software side, Navion responds to simple hand gestures, allowing you to browse the menu, choose or switch routes, or select relevant points of interest, all without taking your eyes off the road. They also offer a companion mobile app that allows you to set a route, save your favorite spots, and keep track of your vehicle's location. Although it's not technically available to the average consumer yet, they just raised $80 million for their Series C investments. Automotive giant Porsche led the funding round, and Hyundai also got in on the action, with both aiming to have the technology implemented by 2020. The future of driving will be here sooner than we think. Next up at number 4, we've got the HoloLens from Microsoft. The HoloLens is a self-contained holographic computer that allows you to view and interact with the digital content it projects onto the world around you. Through the use of special sensors, advanced optics, and a holographic processor, it aims to transform the way we work, play, share, and learn. Since first being made available to developers in 2016, there have been hundreds of apps developed for the HoloLens to let you experience the excitement of augmented reality in new and innovative ways. HoloTour and HoloAnatomy are a pair of educational apps that allow users to visit historical sites and global landmarks from the comfort of their living room, or dive inside the human body with living models. HoloProperty allows property developers and estate agents to help their clients imagine what a space could look like even before it's constructed. When it's time to relax, there are a number of exciting games already available, and HoloTube lets you stream 4K quality video onto a virtual screen as large as your wall. Backed by Microsoft's market leadership, the potential for the HoloLens is practically limitless. Coming in at number 3 on our list, the DAQRI WorkSense sets itself apart by leveraging the power of augmented reality to improve the way we work. Powered by Amazon Web Services, it operates within a secure and reliable global infrastructure that helps to maximize performance and productivity. WorkSense combines video, voice, and the power of 3D annotations to allow you to collaborate with your team and offer your audience the chance to interact and provide ongoing feedback based on your real-world visual experience. These same tools also can be used to interact with remote experts who can help deliver a next-gen product support experience. Where DAQRI's WorkSense really shines is the ability to scan and model in 3 dimensions. The high-quality...
So they're connected to what's it called? It's a CAD system, right? It'll actually you look at something, it'll actually craft the 3D structure for that thing. He's going to mention it here in a second.
Camera lets you instantly map your workspace into a photorealistic 3D model that you can share with your team. It also allows you to create models of all of the equipment in your space, so those can be used to plan for repairs, maintenance, and retrofitting. When combined with Autodesk BIM 360 Docs, the Worksense allows you to view designs as full-scale immersive walkthroughs, keeping head office and your whole team on the same page and delivering unparalleled workplace efficiency. Our runner-up at number 2, the Vuzix Blade AR Smart Glasses are a fashionable piece of tech that's designed to provide you with an endless array of relevant contextual information. The perfect companion to your smartphone, the Vuzix Blade offers revolutionary hands-free interaction in the form of a see-through viewing experience. Vuzix has constructed a Cobra 2 display engine to power its proprietary waveguide optics, allowing the Blade to display relevant information on top of the real world. Everything from patient data to driving directions, restaurant menus, and weather alerts is instantly available, all without the need to ever pick up your phone or look at a second screen. Unlike most AR goggles, which are clunky and obtrusive pieces of hardware that most people wouldn't feel comfortable wearing in public, the Vuzix Blade is a sleek piece of technology that looks and feels like a solid pair of sunglasses. Despite the compact size, it has an impressive array of features, including an internal battery, frame-mounted touchpad, noise-canceling microphone, a micro SD storage slot, and an HD camera, as well as sporting full Bluetooth functionality. Vuzix Blade lets you experience the digital world hands-free. Alright, here it is, the moment you've all been waiting for. The top piece of augmented reality tech on the market is the Magic Leap 1. The Magic Leap 1 offers a far more immersive experience than the standard augmented reality headset. By allowing natural light waves to combine with layered synthetic light fields, the Magic Leap 1 triggers neural signals that travel from the retina to the brain, offering an experience that is unbelievably realistic. Magic Leap 1 is inspired by human physiology, and its array of cameras, speakers, sensors, and optical relay works smoothly with the superpowered processor to generate unique input that stimulates the visual system in a way that is unparalleled in the augmented reality industry. Using cutting-edge technology, the Magic Leap 1 creates contextually aware objects, which means that the zombie crawling across your living room is going to have to take the long way around your coffee table. It employs a spatial audio system that adds an immersive layer of realism by relaying locational audio with accurate distance and intensity, so you don't just have to rely on your eyes to know what's going on around you. On top of all of these great features, they're developing an optional insert for those of us who require prescription eyewear, letting everyone experience augmented reality with crystal clear vision. Throw in the Magic Leap 1's control and you've got 6 degrees of freedom, all without any additional external sensors. To maximize the potential of their groundbreaking technology, Magic Leap 1 has developed its own brand new operating system, Lumen OS. Fully optimized for persistent digital content, environmental recognition, and high-fidelity performance, Lumen is designed to bring cutting-edge visual experiences to life. To maximize your freedom, the integrated GPU and CPU is housed in a portable, super-powered light pack, which clips right onto your pocket. Well, there you have it. 5 pieces of groundbreaking augmented reality technology that are changing the way we work, play, and live. Let us know which one you're most excited about in the comments section down below. Thanks for checking out the video. Don't forget to hit that like button, subscribe to Techno Nerd, hit us up on social.
Anyway, like I said, there's a lot going on. Lots of conversations, even in the local trade breaks, about augmented reality. Detroit News had one recently that I thought was really good. This guy right here. This is much more in the game realm.
Mark Swearick may look like he's just taking pictures, but he's actually defending Central Park from virtual militants. Swearick, a game creator, is using augmented reality to bring video games to life.
So I'm no longer having my digital experience in front of a monitor at home behind my laptop or my tower computer. You're going to see the interface disappear and the content will just kind of evolve around you.
Augmented reality, or AR, overlays the real environment with digital components, allowing the two to interact. Squarek wants to transform the entire world into a video game, where gamers create their own levels, heroes and monsters, all tagged with GPS for others to find. Experts say advances in wearable technology sensors will help it go mainstream.
We're seeing that 2014 is the year of the wearable, and we're seeing that the tablets and the smartphones are starting to get shed, and we're seeing that these wearable technologies or gesture-based technologies are coming out. So it really is exciting times, and we really are on a tipping point.
But others say AR will need practical uses before it can truly flourish.
We've got the building blocks of the technology here right now. It's just implementing them in a product, showing consumers that the product has value and can do things better than they've been doing before. That's where I see the tipping point coming, and we're very close to that.
For now, the enterprise industry is leading the charge. This concept video by Deloitte shows how AR could assist in performing complicated procedures in the field.
Let me help you out with that.
Or provide expert help from a remote location and in real time.
You're giving an entire new class of workforce that could be 5-10 times the number of people that you had sitting at a desk access to information. That's fundamentally revolutionary.
You're looking for the first door on the right?
Brian Ballard makes software for wearables. He says it's just a matter of time before AR becomes fully integrated with our lives, further blurring the line between what's real and digital. Salim As-Said, Associated Press.
Again, a lot happening in the technology slash this guy here space. Okay? A lot going on. So I believe this guy's still around. Let's see, one of these is not here anymore. We'll find out in a second. Huge story, right? All of this cyberbullying stuff, right? Social issues. I mean, we know we're living in a different world now, okay? So having your typical superhero or superhero model is not necessarily going to be what's coming, right? Does that make sense to everybody? We have to start addressing some of the other issues. So social type things are going to start coming into our space, right? So anyway, there's a lot of that kind of stuff going on. Let's see. Let me see this guy here, if he's still around too. That's a good one. Adaptive game design, right? Biomass. There's a whole bunch of things that Borderlands. These are games that are adaptive, right? The term adaptive gaming, right? I'm just going to say that, in generally, right? There's going to be a lot more of the simulation type of games going on, right? Something that recently came to my desk, right, is the idea of esports. Right? McComb's actually reviewing the possibility of creating an esports team, right? I think it's a good idea. I think there's a lot of people that would be interested in it. I'm in shock at the number of people that go to these things, right, to these sort of coliseums and, 20, 30, 40, 50,000 people watching somebody play Overwatch.
Oh yeah,
right?
it's huge. The amount of money that players are giving too is...
Oh, it's unbelievable, right? Literally the college is thinking about creating a team. Stay tuned on that. I have this funny feeling over the winter semester here and summer semester I'm going to get dragged into a few meetings. But I think that's a good possibility of stuff happening. So let's just do this. Investment in video game companies. This is not exactly that. ESPO. Right. Let me go back. This is probably a good one here. So, Take-Two Interactive, Tencent, Activision, Electronic Arts, Capcom, right? These are, look at the prices of the stocks on the right-hand column there. This is pretty recent material. Right? Electronic Arts is $100 a share. Ford Motor Company's $9. Right? Tencent, $41. Activision, $55. Capcom, $23. Right? I mean, we're in the space with these guys. Okay, look at Google's, just crazy. But reasons to invest in the video game industry. Right? The sort of interesting one is the Nintendo and specifically the Switch, the sales numbers for the Switch. How many of you guys got a Switch? I'm surprised. Come on, fess up. You don't have a Switch.
I don't play video games. I
Not
haven't
anymore.
played much either, but I just like the idea of having a constantly take much of the place. It's
Yeah.
a really unique idea.
This is a huge deal. Huge deal.
Oh, the portable one they're making?
Yeah, it's so you can play it on your home TV and then literally, I gotta go out, connect it, and play it.
Those glasses, those one glasses that just, they were a display.
Mm-hmm.
They were just a display. That was it. Well, that was the best thing of it. Because that means that it's just like a monitor on your face.
Mm-hmm. I like the second one, the Blaze.
Yeah, that's what we're talking about.
Yeah.
Because that one is just a.
They're small. It's very cool stuff. Again, there's a whole bunch of stuff you can look at with regard to this. Let's take a look at something else. This is, again, that's just Motley Fool. You log on and you look at it. You know what I'm saying? Video games. Here we go. Don't just play the game. Learn about investing. Right? And it talks literally about how to invest in video game companies. I mean, 5 years ago, folks, this was not even on the horizon. That's how fast this is taking off.
Oh, yeah, that's a good idea. Which one's? Probably Activision. What's the other big one?
7 video games while they're cheap.
No, Blizzard won't be around for long.
What is it? Oh, Hong Kong thing.
New report shows the cumulative investment in video game firms last year was just short of $6 billion. And that's a lot of money, folks. $22 billion was spent on mergers and acquisitions. Let's see, Epic Games, October, wait, right? Tencent, Epic. I mean, MMO games and things like this are still going to be around, but 5 biggest investments for 2018. $1.25 billion for Epic. Doyo, $630. Shanda. Voodoo, $200 million. That's all. I thought it was more than that. Digital Capital. Worldwide game revenues to hit $200 billion by 2023. That's 3 years from now. And that's a lot of cash, guys. Anyway, I think it's pretty clear the amount of money. Let's just see how my friends. Investment in Unity. $6 billion. Rising or raising up to $525 million. This is July. Canadian pension plan. Wow. Unity was targeting an IPO in the first half of 2020. Might be something to think about. Riccatello is still in charge. Anyway, questions on that stuff? Anyway, not to be outdone, I mean, Apple has their own VR system built into their phones, right? ARKit is built right into the, what is it, iOS 11? Into the, what's the latest phone they have? iPhone 11?
It's like an XR or something like that.
But it has, I think they actually demoed it at the phone release.
iPhone 11, you're correct.
And they actually, it has ARKit built into it.
Is that what the third camera's for?
I believe so.
Apple always builds things in and then just leaves it there. Well,
Unless they take away headphone jack.
no, I'm saying they build in a bunch of things. Like, there's a bunch of biometric stuff in your phone that you don't even know about already. They just kind of leave it there. I think they just develop on it. I don't know what to do.
I think this is the one, actually.
We found that slim phone cases weren't that protective, and protected phone cases were ugly. So we designed a lot of phone cases.
We're just off to China on our new mission to create the world's best.
This is iPhone 11, the next generation of iPhone, and it is jam-packed with great new capabilities and an incredible new design.
iPhone 11 has a beautiful anodized aluminum glass design. And that glass is the toughest ever in a smartphone on the front and back. And the glass that surrounds the camera has a sculpted 3D geometry, and it was precision milled down from a single piece of glass.
Exclusive new games made for iPhone, iPad.
Easy. We are so excited about Apple TV Plus that we wanted to do something really special. And so starting today, when you buy an iPhone, an iPad, a Mac, or an Apple TV, you'll get 1 year of Apple TV Plus included for free.
We are thrilled to launch Apple Arcade on the App Store, the world's first game subscription service for mobile, desktop, and TV. Apple Arcade is the only place you can get unlimited access to over 100 groundbreaking, exclusive new games made for iPhone, iPad, Mac, and Apple TV. You can't find these games on any other mobile platform or subscription service. No game service has ever launched as many games at once, and we can't wait for you to play all of them. Apple Arcade is available starting on September 19th. We'll be introducing over 100 new games to our launch catalog in the weeks ahead. So how much does unlimited access to all these amazing games cost? Just for...
Where is the doggone thing?
Think that video games are going to be here to stay, or are they just
What's up, you guys? Eddie at Fliptronics. We're going to be checking out 7 of the best high graphic games to play on the iPhone 11. Alright, so I've got a great list for everybody up.
There is a demo that I saw a while back that actually uses the 3D game engine. It's an AR. That's probably what I should. Engine demo. Yeah, here's an AR kit example. Anyway, question. So does everybody know how this works? How the AR stuff works? How does it work? How's it work?
Doesn't it uses the camera that you have in existence to get the picture and some sort of geolocation thing to be able to track where you're moving around in the space?
Okay.
Now what are you looking for?
Hang on.
Are things that are in your phone?
Mm-hmm. How do I get to Outlook? How do we get to Outlook? I've got some demos of stuff that students have done here. I can show you. But essentially, what it is you make up a card that has a QR code body on it, right? And, that, of course, I can't do anything with it. Tell you what I'm going to do. I'm going to put up the last piece of this, and then I'll show you a demo of some augmented reality stuff that we do here at Macomb. But let me bring this guy up. So there's been several questions. I don't think we've done this quantum computing thing, have we?
We talked about it.
We talked about it, but we didn't take a look at it, right?
No, not.
Right. All right, so let's talk about what's going on here. So one of the recent really big technology things that's going on right now is the whole idea of quantum computing, right? And we've talked about it, and it's the I think it's an attempt to sort of solve problems that we haven't been able to solve prior to coming up with this plan, right? But it's, in the current world, everything's either 0 or 1, right? It's a binomial problem, right? It's on or it's off. In the quantum space, it's maybe a 0 or maybe a 1 at the same time, right? So I'll let Mr. Gill talk about this. He's quite a guy.
Last talk coming up. Dario Gil will take us into a quantum world. Dario is the Vice President of Science and Solutions at IBM Research, where he leads over 1,500 engineers that are researching in technologies in physics, math, healthcare, life sciences, and others. And while some of you will think a quantum world, that's too far out, I'm very sure Dario will tell us otherwise. So come up here on stage, please.
Thank you. Thank you. I was joking with Mark that we couldn't pick an easier topic to end the day than quantum computing. But I'll try to make it, entertaining and hopefully easy to understand. I'm going to start with a reference to this term of beautiful ideas. And it came from hosting a filmmaker about 1.5 years ago in the laboratory I just showed you at the T.J. Watson Research Center in Yorktown Heights. And he was a filmmaker that directed this documentary called Particle Fever that I don't know if you've had a chance to watch, but I highly recommend it. It's about the team that was pursuing the discovery of the Higgs boson in the largest physics experiment ever conducted. And a major character in the film is a professor from Stanford. And at the beginning of the film, he said something that really captivated me. He said, the thing that differentiates scientists is a purely artistic ability to discern what is a good idea, what is a beautiful idea, what is worth spending time on, and most importantly, what is a problem that is sufficiently interesting, yet sufficiently difficult that it hasn't yet been solved, but the time for solving it has come now. So I want to tell you about this beautiful idea whose time for solving it has come now. And that is the possibility to create quantum computers. If you look at how we have created the basis of the information revolution, and you trace it back to other beautiful ideas, like what Shannon taught us, to think about the world of information abstractly. If you look at, an old punch card and DNA, we've come to appreciate that both carry something in common. They carry information. And Shannon told us that this world of bits could be decoupled from its physical implementation. That was really interesting, but in fundamental ways, it went too far, leaving too much physics out. So here is two scientists that work at IBM Research. Charlie Bennett on the right continues to work in our laboratory and is an IBM fellow. And they asked the question at the time of, is there a fundamental limit to how efficient number crunching can be, computing can be? And when they asked that question as physicists, they ended up with a very surprising answer. They found the answer to be no. It turns out that number crunching can be thermodynamically reversible. This led to an exploration of what is the relationship between physics and information. And there was a now famous conference that was jointly organized between IBM Research and MIT at Endicott House, where this topic was explored in more detail, and the plenary speaker was none other than Richard Feynman. And Feynman proposed in that conference that if we wanted to simulate nature, we should build a quantum computer. And I'm going to explain you what that means and how it's created and the problems that it will solve. But first, I got to tell you what is the fundamental idea. The fundamental idea, just like we have bits in the classical world that can be a 0 or a 1, in a quantum computer, you have qubits, which stands for quantum bits. Now, the difference is that they can be a 0, a 1, or both at the same time. That exploits a principle of quantum physics called superposition. And it sounds weird and crazy, but it's true. Now, to give you this unease that you should feel when you talk about quantum information and quantum computing, I'm going to give you a very simple example, a thought experiment that also happens to be true. So let's imagine that we're going to solve this problem. The problem involves you have 4 cards. 3 are identical, 1 is different, 1 is a queen. We shuffle the cards and we put them face down, and the problem we're going to solve together is find the queen. We're going to be assisted by 2 computers. One is a classical computer, one is a quantum computer. So what we do is we turn them down and we load them into memory. So we use 4 memory slots. The cards are identical, we put zeros. The one that has a queen, we put a 1, right? So in our 4 slots, we'll have 3 zeros and 1 is a 1. An exploration of what is the relationship between physics and information. And there was a now famous conference that was jointly organized between IBM Research and MIT at Endicott House, where this topic was explored in more detail, and the plenary speaker was none other than Richard Feynman. And Feynman proposed proposed in that conference that if we wanted to simulate nature, we should build a quantum computer. And I'm going to explain you what that means and how it's created and the problems that it will solve. But first, I got to tell you what is a fundamental idea. The fundamental idea, just like we have bits in the classical world that can be a 0 or a 1, in a quantum computer, you have qubits, which stands for quantum bits. Now, the difference is that they can be a 0, a 1, or both at the same time. That exploits a principle of quantum physics called superposition. And it sounds weird and crazy, but it's true. Now, to give you this unease that you should feel when you talk about quantum information and quantum computing, I'm going to give you a very simple example, a thought experiment that also happens to be true. So let's imagine that we're going to solve this problem. The problem involves you have 4 cards, 3 are identical, 1 is different, 1 is a queen. We shuffle the cards and we put them face down, and the problem we're going to solve together is find the queen.
Okay, so what is the probability of finding the queen in general? 1 in 4, which translates into how many, checking each one, on average, how many cards do you have to look at to figure out where the queen's at?
2 or 3, probably closer to 2.
On average, 2.5. Okay.
We're going to be assisted by 2 computers. One is a classical computer, one is a quantum computer. So what we do is we turn them down and we load them into memory. So we use 4 memory slots. The cards are identical, we put zeros. The one that has a queen, we put a 1, right? So in our 4 slots, we'll have 3 zeros and 1 is a 1. We load them on the 2 computers. Now we ask to write a program to find the queen, find the 1. How would it be done classically? You would go and pick a random number, you don't know where it is. You go, look under that memory slot, see if it's a 1. If not, you go to the next slot, and so on and so on. On average, it would take you the equivalent of 2.5 turns to find it. It turns out that with a 2-qubit quantum computer for this problem, you can always solve it in 1 shot. So that uneasy feeling that you have now should be an explanation that quantum computer is not just about building a faster computer, it is building something that is fundamentally different than a classical computer. Now, a way to think about it, an abstraction of it, is that a quantum computer is always going to have a classical computer next to it. They have to go together. So you have a classical set of bits, right? The problem that you're trying to explore. And what the quantum computer is going to allow you to do is to explore this exponential number of states, this 2 to the n, where n is the number of qubits that you have. So now we have relatively small quantum computers with few qubits, but just think of the number that by the time you have 50 qubits, you have 2 to the 50 states. That's a phenomenally large number. But in the end, after you explore this number of states, you go back to a classical output, a string of zeros and ones that you interpret with a normal computer. So why is this interesting? And I think in this audience, I don't need to, explain in great detail, what exponentials mean and why 2 to the 50 is a very large number. But it's still, I think it's an interesting way to communicate the power of this, and I like to map it to some problems. But I like to go after this apocryphal story that actually IBM used in the 1960s to explain to people the power of exponentials. And it had to do with the person who invented chess that goes to the emperor and says, well, here's this wonderful game, and asks, what do you want in return? And the person who invents it is, give me a grain of rice on the first day for the first square, and the second day you give me twice as much, and on the third square, third day, you give me twice as much as the day before. And the emperor agrees promptly that that seems quite reasonable. And after a week, you only have 127 grains. After a month, you have more rice than you'll eat in your lifetime for sure. But just by the time you get to the end of the chessboard, you have more rice than Mount Everest. So there are a large number of problems in the world that have this characteristic that they blow up exponentially. And a dirty secret in the world of computing is that we obviously talk a lot about all the things that computers can't solve, and can solve a lot of things. But then there's a lot of things that computers cannot solve. And very interestingly, they cannot solve it now nor ever. And the reason is because they have this exponential built into them. So take as an example this fairly simple equation, factoring. So if I have a number m that is made out of the multiplication of two large prime numbers, and I only give you m, and I ask you, find me p and q, it turns out that that is phenomenally difficult to solve. There's no other way but to divide it sort of sequentially by prime numbers. So, in fact, it's so difficult, we use it as the basis of all encryption. But if you had a very large universal fault-tolerant quantum computer, which is many, many years away, you could solve that problem in seconds, what would take billions of years in a classical computer. That tells you something about the power of what is going to be possible. Take chemistry as a problem, because it also has this characteristic that it blows up exponentially if you try to calculate it. This equation that you see here is very interesting because it's predicted to occur at the ocean floor near volcanic sites, and famously it's been hypothesized to be the basis of the formation of life on Earth. But if you take a molecule like iron sulfide and you try to do relatively simple calculations with a normal machine, it turns out that we're not very accurate. And the reason is that molecules form when electron orbitals overlap, and the calculation of each orbital requires a quantum mechanical calculation. So for that simple molecule, you have on the order of 76 orbitals, and 2 to the power of 76 is intractable with a classical computer, so we cannot solve it. Again, on this theme of our assumptions that computers solve everything, but they don't, if you look at calculating, for example, the bond length of a simple molecule like calcium monofluoride, we still get it off by a factor of 2, even using the largest supercomputers in the world. To me, this has been very interesting, this recognition of all these problems we cannot solve. It's also true in optimization problems that are the basis of logistics and routing and portfolio optimization. There's tons and tons of problems in which at best we do approximations, but we're far from optimal because the number of possibilities is enormous. So if there's one message I want to be able to come across is that we have these easy problems, which is the world where classical computers fit and the problems it solves. But then there's these other hard problems that go outside. And if you don't believe that P equals NP, which I would say the majority of mathematicians don't believe that that is the case, that those problems are hard for a reason, the only avenue to go and tackle that, aside from approximations, will be through the creation of quantum computers. So where are we? We believe that small practical quantum computers are going to be possible, and we're building them now. It requires reinventing the whole stack. The device is different. It's not the traditional transistors. As an example, this is the device we use for the quantum computers that we create at IBM based on superconducting Josephson junctions. And you're seeing an example of one of these devices. It's a superconducting device. And because it's superconducting, you have to cool it. So this is what a small quantum computer looks like. What you're seeing here is something called a dilution refrigerator. And this quantum processor sits at the bottom of this refrigerator at the nice temperature of 15 millikelvin. So that is colder than outer space, where we have to put this quantum processor in. This is what, for example, a 16-qubit quantum processor looks like. And, inside you see the square where the qubits are, and you see these squiggly lines, which is these coupling resonators that allow you to send the information and couple to the qubits to send the information. This is what the wiring looks like into the refrigerator going into a quantum processor. Is these coaxial cables, and because the way you send information to a quantum processor is through a series of microwave pulses that go in, and then you're able to take it out. Now, if you look at pictures of what computers were like, right, in the 40s and the 50s, it's kind of like where we are today, right? That's what, a quantum computer, that's the signal processing required to actually send all those signals down the coaxial cables. It looks like that. But we've also seen this movie before, in the sense that we know how much progress we have made from those early systems. And while we don't anticipate that quantum computers will be on your phone, because they require cryogenic cooling, we definitely believe that access to quantum computers in the cloud will be something that people will be able to leverage behind the scenes, even not knowing. Because we believe that, we created a small quantum computer last year, and we made it available to the world on something called the IBM Quantum Experience. And all of you can go and log in and have access to this. It's available for free. It's a 5-qubit machine. And since we launched it, we have over 36,000 users from over 100 countries that have been doing it. And 15 scientific publications have gone on it. And people are learning how to program and to learn about this new world and what is being created. And you can actually run things on this. So I was telling you about these chemistry problems. So this is an example of the expected theoretical calculation and the actual calculation on a small quantum machine of hydrogen. So we're starting to solve small problems, and what is coming in the years ahead, in the next few years, will be machines that no classical computer will be able to emulate. Because by the time you have order of 50 qubits, think about that, that's 2 to the 50 states. And no classical machine will be able to emulate what that can do. And that is new territory, and that's the territory we're all going to enter. And now is the most interesting part, because it'll be the path of discovery of what we can do and what value we can create on problems we couldn't solve before. So I'll close with Feynman, who proposed this original idea of creating these quantum machines, and his, inimitable style. He said, nature isn't classical, damn it. And if you want to make a simulation of nature, you better make it quantum mechanical. And by golly, it's a wonderful problem because it doesn't look so easy. Thank you.
So, it's not quite as easy as they say it is to get on the box, because I've tried to do it twice now. I have a problem that I'd like to try out. But the point is, the hardware is there. This is a 1-year-old, that's a 1-year-old presentation to get problems on it, right? The biggest issue is the fact that you have to set up the code in such a way to be able to take advantage of massive parallelism, right? So anyway, I'm about a minute and a half away from showing you the example of AR that we've been doing here. Or an example of one of the projects we did here using AR. Anyway, questions on any of this stuff? It's pretty interesting. All the way around, all the things that are coming up. The game industry in itself. I think there's lots of very interesting times coming. As I said, I think we're going to see some very interesting advertising coming up in some of the games, especially the big ones, right? The big games that are games that have a lot of following, right? Like I said, I'm about a minute away here from having this thing downloaded. It's a big MP4 file. So, anyway, questions, thoughts on any of this? So, as I said, Thursday we will do a talk on AI. It'll be a lot more scripted than this one was. And then you can ask any questions you have left remaining on your project, right? Saturday night, betas go in, right? And it has to have, the slide 4 will not be what's unique. It'll be, here's what I promised to deliver based upon your email document that you sent in. And Tuesday we will kick it off one last time. And I'm looking forward to some very good projects based upon some of the descriptions. Right? Remember, it's got to have all the shopping list concepts in it, or at least a good majority of them. In some cases, it's always not easy to incorporate all of that in it. Alrighty, looks like it's downloaded. I'm going to close this guy. And let's go to here. Come on now. Where is that guy? Where is it? Presentation. I'm just throwing it on my memory stick here. Any other questions about any of this stuff? Remember, bulletproof your presentation, folks. So here's a predecessor of yours in the 2050 course, I believe.
Hi everyone, today I will be talking a little bit about my mobile game development project, AR Archery. I used Unity 2017.2 coded with C# and the Vuforia piece for AR. Let's go ahead and take a look. What we have here is a brief little demo from what it looks like when you're holding the phone. Let's take a closer look at what's going on the screen. Okay, we have the game loading up right now. Okay, as you can see in the lower left we have a little points counter that updates, and in the lower right we have the power meter. So you adjust that to determine with physics how far the arrows are going to fly. And in front of us we have the little paper with the Vuforia piece, and when we get close enough it activates the 3D model as the target. And every time that we touch the screen an arrow pops out according to the power meter there, how fast and far it'll fly. And every time an arrow hits the target, it adds a point. Thanks everyone, I'll be sure to leave the install file for anyone who wants to play around with my project.
Anyway, just some food for thought. Alrighty, if you have no questions, I will see you on Thursday. we'll do one last hurrah for the semester. He's now at U of M Dearborn, finishing off his degree.
Good luck with today's lesson.